So, good day, everyone. So we have irreversible trimolecular-type third-order reactions, which is another type of um, irreversible reactions. So trimolecular because we have three molecules present in the reaction, A plus B and D. So we need to find an equation for the kinetic rate of reaction. So it could be A, B, and D. So as we always do, we assume A as our limiting reactant. So with that, we have negative RA capital is equals to negative dCCA dt is equals to K CA CD and CD. So we have this as our working equation. So we have four variables, CA, CB, CD, and T. So we can't do separable, so we need to find a relationship between CB to CA and CD to CA and so on. So for that, we will be using the BCA table. BCA table. Before change after. So have A, B, D, and the products. So again, we usually do not care about the products, so we'll just put because we can only manipulate during the reaction the it's entering the reactor. So we have for our A starting, we have CA0. Then for B we have CBO. For this CDO. Then for the change, since we assume that that A is our limiting reactant, so we start with negative CaOXA at any given time XA, and this is for all the reactants. And then after, we just have to add all of this. So you have that for A, for B, and for D. So just have to change this into the proper subscripts, and all of this is equals to CA. This one is CBO. This one is B. Oops. That. This is So we now have a relationship between CD, CB, and CA in terms of CAO and XA. And if you remember, we have also the relationship between DCA and XA. We derived this previously on our previous video, right? So we have DCA is equals to negative DCA is equals to CAO dXA. Substituting it all here, so we have for DCA we have this CAO dXA, and for CA we have this. For CB we have this, and for CD we have this. Ah, there you go. So what we can do is, since we have XA and D as our dependent variable, so we can do separable by variable separable. Separation of variables. KTT. So a trick here is we factor out CAO. Cut this one. And then for each of these terms, we multiply CAO over CA. Okay. There. So this would become that, and we will be left with a CAO. Same goes here. So that, and that. So we now have CAO, CAO, and CAO, 3 CAOs. So we could CAO cube, combine those three. So after combining those three, we can cancel the CAO here, and then also this one. So may mo siyang squared. So after cancellation, wala na siya. Then this one will become squared, and we can transfer this here on this side. KCO squared dt, and then we can integrate. Or first, we have to, para dali lang ang integration, para gamay lang ang ato ang variables, we could let m be equals to that, and n be equals to that one. TFLs. So change this into M, then change this into M. Okay, and then we will be integrating. This one starts from 0 to XA. XA. And meanwhile, for DT, it will be from 0 to T. And as you all know, we will be using um, using partial fraction decomposition. So if this is equals to a over this, so it's just linear, then b over this, then plus c over this. So actually this is a dxa dxa dxa, but para dali lang sa ton ang decomposition, so i-omit sa nato na. So after multiplying, cross multiply all of this, we will be getting 1 is equals to a times that 1 plus b times that one and this one, and plus c times this two. Okay, for xa, no, we need to expand this first. So expanding that, so after expanding, we will get this equation. So time to manipulate this. So isolating the coefficients for xa squared, and the constant. So for xa squared, we have this, and this. We have 0 is equals to, since wala tayo dito, xa squared on the right side, on the left side of the equation. So taking the coefficients, we have a plus b plus c. Now for xa, we have this, ano, should be lahi na color, correct? This one, and this. So again, start with 0 is equals to negative am minus am minus bn minus b minus cm minus c. So we can do is multiply this by -1, so all of this will become positive. There. Then lastly, for the constants, we have 1 is equals to 1 is equals to, so we have this, into y. That, and so we have AMN plus BN plus CN. So we have ABC, 3 equations, and we have 3 unknowns. So solving for A, B, and C by manipulation of this, solving simultaneously of these 3 equations, makakuha tayo value for A, B, and C. So we'll get these equations for our constants A, B, and C. So substitute all of those into this. For A, we have that. For B, we have that. Since -1, so kung walang negative, change that. And for C, we have that. Yeah, and then input the XE, and then integrate. Every one of these 0, 0, 0, XA, 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 and all of this is equals to this. Okay. So we have this. So integrating this, we will be using ln for each of these, and this is just t. So after integration, we will be getting this equation. So kana. So all of this has the limits 0 to xa, and this one is just k 0 to t. So first we need to apply the limits before we proceed with simplification. So applying the limits and all of this. So this is just t, and for this we have minus ln of 1 minus 0 So this is now our equation after applying the limits. So as you all know, ln of 1 minus 0 is ln of 1 and ln of 1 is 0, so we can cancel that one out, and then ln of m is just ln 0 there. And then applying for this 2, applying the properties of ln, since minus, so divide. So we have ln of m minus x e over m, and then for this one we have ln of n minus xa over n. So very kataas na equation. There. So all we need to do here is prove that we have indeed achieve the right equation that is stipulated in Levenspiel. So we need to do some simplifications, and then we have to substitute back this m is equals to CBO over CAO, and for n is CDO over CAO. So first you need to see what is in your what is in the Levenspiel book. So what we need to do is just again substitute back this to our equation. So for every m we have this, and for every n we have this. By m. Okay, so simplifying, we could do is multiply this with CAO. So ang 1 multiply into CAO, so this would become CDO minus CAO. Same dire CAO, CAO. Kansha, okay. Kansha is combine. We have this. Delete minus CAO. Delete. Then this one is minus CaOXA minus CO this is minus CDO minus CaO XA. Whew. So if you remember, these two, so we could replace this with CD, negative. We could replace that with CD, and the other one we could replace with CD. And then we can cancel some CaO. So cancel this one, cancel, and the last one. Okay. So after cancellation, we have that and that. Also for this, have that and that. So in the equation of in the Levenspiel, it's CBO over CDO, then CD over CDO. So diba remember, if you have negative property of if you have negative ln of A over B, this is equals to positive ln of B over A.